All right, so as we begin our journey here with practice test number 2, let's go ahead and take a look at questions 1 and 2 in this video because they are both dealing with the same concept. And the directions for number 1 here are decide whether the ordered pair is a solution of the given system. Well, what does that mean? Well, let's see. We've been given two equations, two linear equations, meaning we could take each of these equations and graph them, just like we've been doing. And I'm going to go ahead and I'll just make up two random lines here. And we'll pretend that each of these lines is corresponding to each of these two equations. And what they're asking is this. The point at which these two lines intersect, is that point 4, -6? And if the two lines intersect at 4, -6, then that is the solution to the system. If, however, these two lines do not intersect at 4, -6, then this point is not the solution to the system. Well, how do we test to find out whether or not 4, -6 is a solution to the system, meaning it's the point at which these two lines intersect each other without having to graph? Well, to do that, instead of graphing, we're going to take this point and plug it into each of our two given equations. And when we do that, we're looking to get a true statement for both of these equations. So when we plug in the point, we want to get a true statement for each of these equations. If we get a true statement for both, then this point is a solution to the system, meaning that the point 4, -6 is where these two lines cross. If we get a true statement for one and not the other, then the answer is no, this is not a solution, meaning the point 4, -6 is not where these two lines cross. So let's go ahead and do that. Let's plug in this point into each of our equations and see what happens. So of course we remember that this is our x, this is our y. And so let's go ahead and take the point and plug it into the first equation here. So we have 4 plus, and then we're plugging in our -6 for y equals -2. Well, 4 plus a -6 is really just 4 minus 6. And of course, if we subtract 6 from 4, we are indeed going to get -2 equals -2. And is this a true statement? Does -2 equal -2? Well, of course. So we get a true statement when we plug our point into equation number 1. Well, how about equation number 2? Let's test it there. So again, we're going to take 4, plug it in for x, minus -6 equals 10. 4 minus a -6, well, if we distribute this negative through, we're going to get 4. Negative times a negative gives us a positive. And of course, 4 plus 6 does indeed equal 10, so we have 10 equals 10. Again, another true statement. And so since when we plug in 4, -6 to both of our equations, and each time we get a true statement, we can definitively say that 4, -6 is a solution to this system. So it is a solution. So if we were to graph each of these lines, we would see that the two lines intersect one another at the point 4, -6. Well, how about number 2? Let's take a look at it again. Same directions. Decide whether the ordered pair is a solution of the given system. So we're going to take our point, so -6, 2, our x and our y. And let's go ahead and plug this point into our first equation here. So we have 4. Let's go ahead and plug in our x plus plug in our y equals -26. Well, 4 times -6, that gives us -24 plus 2 equals -26. Well, let's see, -24 plus 2 equals -22. So what we end up with is -22 equals -26. Is that a true statement? No, that's a false statement. And so right away, we don't even have to plug this point into the second equation because, remember, in order for the point to be a solution, it has to be true or work for both equations. So as soon as you plug it into one equation and it doesn't work, you get a false answer, you can go ahead and stop there because you know that it's not a solution to the system because it has to work in both of your equations. All right, so here we are going to say that no, negative 6.2 is not a solution to the system. And that's all you have to do for question number 1 and 2. I will go ahead and see you at question number 3 in our next video. Joe Brownlee with Palm Beach State. Thanks for watching.